Hello friends, welcome back to lecture number 5. In the last class, we studied about remainder theorem. Okay, so after studying the remainder theorem, most of our problems of the number system can be solved. So let's just see how we can do this. Uh, Now see some more concepts and then we will move on to the questions. Okay. So see how to deal with large powers. Okay. See, whenever you are given to find out the remainder, sometimes you will be given very large power. Okay. So how will you do that? Because now we have already only studied that if some simple calculation is given, simple in the sense it is not given like x to the power 975. Okay, like if for example you are given 563 to the power 975 divided by 7. Okay, so I am calling this as not simple, whereas 63 into 64 into 66, okay, divided by let's say 62, if you find out the, if you have to find out the remainder, I am calling this thing as simple. Okay, so I hope everybody is clear with what I am saying. I am trying to say that basically if you have very large power and the calculation just look unsolvable, because you try to solve this 563 to the power 975, no calculator will give you any answer. Okay, तो जहाँ पे कैलकुलेटर नहीं काम करता वहाँ पे हम काम कर लेते हैं. अ, तो देखिए, सिंपल मेथड्स देख रहे हैं अभी. जब बहुत ही लार्ज पावर होती है, सो व्हाट वी ट्राई टू डू इज वी ट्राई टू ब्रेक द नंबर इन टू फॉर्मेट्स. ओके, one is ax plus 1 to the power n divided by a, and another is what? Hello student, welcome back to our lecture number 5 of the CSAT course, and my name is Daksha Jain and you are enjoying this course with me. Now let's move forward. In the last class we saw the remainder theorem. Okay, we saw the remainder theorem. So I told you the basics of the remainder theorem, and I also told you how to calculate with the help of negative remainders. All right, so let's just revise a little bit the concept with the help of an example. See, what we have to do here is that, see, what we have to do here is that, for example, if we take like this simple calculation, we did it in last class, 63 into 64 into 65 divided by, let's say, 66, and we have to calculate the remainder. So using the concept of negative remainder, what we were doing is that I will write this as minus 3. Why? Because see, to be 66, this needs only 3 more. So I am writing this remainder as minus 3 because this is just 3 short of 66. तो थोड़ा सा try to internalize these intuitive kind of concepts, क्योंकि इससे आपको बहुत आसानी हो जाएगी calculation में. And then when you are writing about 66, 64 uh, is just 2 short of 66, and then when you are writing about 65, then it is just 1 short of 65. Okay, so this is what this comes to be minus 6. Okay, this comes to be what? Minus 6, because this will be 6 and you are doing this, so this is minus 6. Now we know we cannot have negative remainder, so basically what we do here is we take the divisor. Okay, and we subtract 6 by this, so the remainder will come to be 60. The remainder of this multiplication divided by 66 will come to be 60. Now in case you want to do it by the regular method of multiplying, then it will be a very lengthy procedure. Okay, it will be a very lengthy procedure. So let's move on. Now we have revised the concept, so we can move on to our next concept. Okay, now look at this. That question according to us was simple. Okay, now we are moving to tough questions. Now what are tough questions? Okay, what are tough questions? I'm not saying these questions are tough in itself. I am saying that basically these are very large numbers. You will get very large number. For example, if you try to do 37, 1, 2, 6, 3, 5 with the help of your calculator, you will not be able to do it. Okay, you will not be able to do it because it will say the such a large number is not allowed. Okay, so I already told you that when calculator doesn't work, we work there. All right. So whenever you encounter such large power, for example, like 563 to the power 12635. Okay, basically what we do here is we do two things. Okay, either we break our number in the form of ax plus 1 by a to the power n, ये कर लेते हैं, और we do one more thing, ax minus 1 by a to the power n. Okay, so we try to reform our number in this format. Okay, we try to reform our number in this format. So you have to remember that whenever we do ax plus 1 to the power n, the remainder will become 1 directly. Why? See, try to understand this. You have ax plus 1. All right. Now to the power n. Now this a is divisible by this ax is divisible by a. So you will get here remainder 0, and then remainder 1 is left, 1 divided by a. Now 1 to the power n, how many times you will do? You will get 1 itself. Okay. So this is how we do it. Similarly, if you get the number in the form of ax minus 1 by n, sorry, ax minus 1 by a to the power n. So basically what is going to happen when you are doing ax divided by a, you are getting your remainder as 0, and then minus 1 is left, and then just do minus 1 to the power n. So if n is odd, you will get minus 1. Then you will have to subtract the remainder. Okay, a minus 1. Okay. And when n is even, then obviously this will become 1, so you will get the remainder 1. So just whenever you are breaking your power in the form of ax minus 1 to the power n divided by a, so what is going to happen? If n is odd, then obviously you are going to get what? Minus 1. But we know we cannot have remainder minus 1. So we will do what? A minus 1. All right, we will do a minus 1. But when n is even, then it will be 1 only, because then it is a positive remainder and we can have positive remainders. All right, so I hope everybody is clear with this concept. Now let's move on. Okay, so I've already told you this concept. So now let's just see how this applies. Okay, so in the last question we have like 37, 1, 2, 3, 4, 5, 6 divided by let's say 9. Okay, 9. So it is asking the remainder here. So now you have ax plus 1. So what is a here? A is 9. Okay, and can this number be broken in the form of ax plus 1? Yes, 9 fours are 36 plus 1 divided by n, and you have raised to the power 1, 2, 3, 4, 6. So now we know here the remainder will be equal to 1. Okay, and if we see like 31 to the power 127 divided by 8. Okay, 31 to the power 127 divided by 8. So basically what are you going to get here is uh, 31 can be written in the form of 8 into 4 minus 1 divided by 8. This is exactly what we mean when we say ax minus 1 to the power divided and n. Okay, so now what is happening here? We have minus 1 as a remainder. Okay, minus 1 to the power as a remainder. Now whether n is even or odd, we have n as odd. Okay, 127 is odd, so we will have minus 1 as remainder. So that means we cannot have minus 1 as remainder, 8 minus 1. So we will have 7 as remainder. Okay, we will have 7 as remainder. So I hope everybody is clear with this concept, that how do you calculate this remainder. Okay, now this becomes very simple. Now let's move on to some questions. Okay, First, let us see uh, an application of remainder theorem. Now it is asking you about, suppose you have to find last two digits of the expression. Okay, suppose you have to find last two digits of the expression. So basically what you have to do is just divide by 100. See, if you want to find the last three digits of any thing, just divide by 1000. Okay, so to find the last two or last three or last four digit, but just divide it by 100 or the number of zeros by which it is asking. So you will get your answer. All right. So now let's see what we can do here. So in this case, you have 22 into 31 into 44 into 27 into 37 into 43 divided by what? Divided by 100. Okay, divided by 100. So we know this is what? This is basically 100 is what? 4 into 25. Okay, 4 into 25. So write this expression and just write 4 into 25. So this 4 becomes 11. Okay. This becomes 11, or you can do one more thing. Okay, let's just keep it 11. Okay. So this becomes 11. Now you have 22 into 31 into 11 into 27 into 37 into 43 divided by 25. Okay. So what I will do here is I will write this as minus 3 as remainder. 25 when divided by 20, I will write minus 3 as remainder. Okay. Why? Because I need to simplify a calculation a little bit. Okay. So for 22 when divided by 25, I write minus 3 as remainder. When 31 is divided by 25, I write 6 as remainder. Okay. When 11 is divided by 25, I write 11 as remainder. Okay, because I don't need to, because if I will divide this 11 and will convert into negative remainder, then it will become 14. Okay, minus 14. But what I am trying to do is I am trying to take the smallest number possible, so that I have to make the least of the calculation. Okay, so now you have 27 here, and 25 divided by 27 will leave what? 2 as remainder. Okay, now you have 37 here. Okay, so 37 when divided by 25, so basically what you are going to get as remainder? 12. Okay, 12. How? See, 37, 25, 1, 25. Okay, you are going to get 12 as remainder. So this is how you do it. Okay, and then you have 43. 43 divided by 25. Okay, so see, 25 2 times is 50. Now 43 is just 7 short of 50. Okay, 7 short of 50. So I will write minus 7 as remainder. See why I am taking minus 7 as remainder here. If I try to divide it by 25 and take positive remainder, okay, so what positive remainder I will get? 18. But do I want such a large number? I don't want that. Okay. So you have 25. Okay. So you have 18 here. You have 18 here. Okay. One times it will go. You have 18 here. I don't want such a large number as remainder. So I am doing what? I am taking this as minus 7 as remainder. I hope everybody is clear with this thing. See, basically, what I do and what has worked for me always when I'm taking remainders. So, whenever I see that any number is close to a multiple, okay, so I will take negative remainders. For example, I have 20. Let's say, okay, like I have 80. 80. Okay. So what is 80 divided by 9? What is the remainder here? See, uh, you know 9 into 9 is 81. Okay. And this is just one short of 80 is just one short of what? 81. 80 is just one short of 81. So I write minus 1 as remainder here, and because remainders cannot be negative, so I make this at 8. Now you can obviously see when 9 eights are 72 and you are getting 8 as remainder only. Okay, so this works. I hope I am not confusing any of you. I am trying to explain very clearly. Okay, Let's just see one more example in which we can take negative remainders in the form of multiples. Okay, so let's take 119 divided by 11. Okay, 119 divided by 11. So my point is I will get minus 2 as negative remainder here. Okay, and then finally I will get what? I will get 9 as a remainder. How? Because I know 11 into 11 is what? 121. This is very easy. And this 119 is just 2 short of 121. So I write minus 2 as remainder here. And because remainders cannot be negative, so I subtract minus 2 from 11. So I get 9 as remainder. I hope everybody is clear with this concept and I'm not confusing you. I am trying to explain you. Okay. Because these concepts are very intuitive in nature, so that's why I'm trying to explain it again and again so that you don't get confused. All right. So I hope everybody is clear here that how I wrote these remainders. Okay, how I wrote this minus 3 and minus 7 as remainders. Now this is left to be 25. Okay, so see what I will do here is I will make these very close to 25. All right, I will make these very close to 25. So let's see how I can do this. See, you have 3 into 2 and this is 11. So this will become what? This will become nearly equal to this. So let's just pair this and this up. Let's just pair this and this up. Okay. And let's just pair this and this up. Okay. Now see, there are two negative here, so they will obviously when get multiplied, so they will get cancelled. So we have only positive numbers here. Okay, think like we have positive numbers here. So this is what 7 into 3 is what 21. 2 into 12 is what? Uh, no, let's take 2 into okay, let's take 2 into 12 only. So we have 24 and let's take 6 into 11. So we have 66. I hope I have taken each of the numbers. Okay. I have taken each of the numbers and then I have to divide it by 25. Okay. So I get what? Here I get again. I'll write minus 4 as remainder. Here I will write minus 1 as remainder. Why? I've already explained you. Okay, and here I will write 16 as remainder. Here I will write what? 16 as remainder because you know 25 twos are 15 and 16 is left. Now you are left with 25. Okay. Now you have 14 into, sorry, 4 into 16 by 25 because again you have only two negative remainders. So 4 into 16. Now you have 64 divided by 25. Now you know what is the remainder. This is easy. You have, it comes to be 14 as remainder. So I hope everybody is clear with this, what I have told, these concepts. These are easy, but the calculation part, it has to be little intuitive. All right. Okay, so see, I am getting 14 as remainder when I am dividing this by 25. But see, we will get 46 as remainder because we already cancelled this 4 now. So we have to multiply this 4 again. Okay, because we cancelled this 4, so we have to multiply this 4 again. So the real remainder will be 56. Okay, the real remainder will be what? 56 when divided by 100. See, because we have to find the last two digits of expression. Okay, we have to find the last two digits of expression, so that will be 56. Why? Because see, we eliminated 4 here, so you can write 14 as remainder when you want, in case just the remainder is asked. But when you are asked to find the last two digits, the number that you have eliminated, you have to multiply by that number. Okay, so multiply your remainder by 4, you are going to get 56. Now I hope everybody is clear with this concept. Okay, just don't make this mistake of not multiplying by 4. All right, so in this way you can obviously do these kind of questions. I hope everybody is clear with this. Now let's move forward. Okay, now see, there is one more rule which is important, and this rule says that if there is a prime number, let's say, so to find the remainder of an expression a to the power p minus 1 divided by p, where p should be prime number, that remainder will come equal to 1. Okay. So this is what, like, take any number, like here 37, let's say, take. Okay. And here it is 83, because 83 is a prime number. So try to remember prime number between 1 to 100. All right, try to remember prime number between 1 to 100. So 37 divided by 83, and this is p minus 1, that is 82. Okay, this is 82. So this will comes to be, this will come be equal to 1. So always look out for the powers here. Whenever you are getting prime number in the denominator and the power is such that it is one short of the prime number p, so obviously just write the remainder there as 1 and your work is done. All right, and your work is done. Okay, now see, there is one more kind of question. Now you are given 136. Okay, you are given 136. So how will you calculate this? All right, how will you calculate this with the help of remainder theorem? Because here it is not coming in the form of ax plus 1 to the power n. Okay, so and this is 136. All right, so how do we do this? So see, what we are going to do here is we are going to split this number into co-prime number. Okay, we are going to split this number into co-prime number. Now see, this is 36. We obviously know this is 36, so this is divisible by 4. So let us take the factors. Okay, you have 4 threes are 12, and 4 are 16. Okay, and 4 fours are 16. All right. Okay, so you can check this calculation as well. So you have two factors, 34, and you have 4 here. All right, you have 34 into 4. Okay, and if you want, you can take it what, 17 into 8. Okay, that will also do for you. Okay, that will also work for you. So you can do either way. Now what you are going to do here is take 107 divided by 144 divided by 136. Okay, divided by 136, and we split this into 107 to the power 144 divided by 8 into 107 divided by 17, uh, and 144. Okay, 144. Okay, all right. So how we are going to do this? Let's just see this. Okay, so when we divide 107 by 8, okay, when we divide 107 by 8, uh, can we make this in the form of ax plus 1 to the power n, or ax minus 1 to the power n? Okay, so let's just see. All right, so when you do this, you will get 104. Otherwise, you will get 117. Okay, so you are not able to make 107 as in the form of ax plus 1. So you are not able to make 101, sorry, 107 in the form of ax plus 1 when you are dividing by 8. Okay. So what we are going to do? So let me first just clear this board. All right. We just need to keep this expression 107 divided by 144, okay, into 107 divided by 17 to the power 1444. Now let's just clear this and keep this expression. All right, 107 divided by 8 and 1444. ठीक है. तो बेसिकली अब यहाँ पे करें क्या, क्योंकि ये x+1 के फॉर्म में तो बन नहीं रहा है, तो इसको डिवाइड करके इसका रिमाइंडर पता करिए. सो लेट जस्ट डिवाइड दिस. 8 one times you will get, and this is what, 27, and 8 threes are, sorry, yes, 8 threes are 24. So you are getting basically 3 as remainder. Okay. So 3 to the power 144 divided by 8 you are getting. Okay, divided by 8 you are getting. So if I do one thing, I take 3 square, and then this will become what? This will become 5, sorry, 7, 2, 2. Okay. Because I am taking 3 square here. Okay. So I am taking 2 from here. And we know the law of indices we already did. A to the power m to the power n is equals to a to the power m into m. So basically what I did is I took 144. I put 722 into 2 here. Okay. So now what is happening? This becomes what? 9. 9 raised to the power 722 divided by 8. Okay, 9 raised to the power 722 divided by 8. All right. So what I am getting now remainder as, now this becomes ax plus 1 divided by 8 to the power 722. All right. And we know what is the remainder when this happens. The remainder is 1. Okay. The remainder is 1. Okay, all right. So, one thing is this. Now, let's just see what is the remainder when this 107 divided by 17 is made in the form of solve for 107 divided by 17 to the power 144. Okay, to the power 144. See, we studied one more theorem, a to the power p minus 1 divided by p. Okay, so that remainder will also come equal to 1, and we know this is prime number. We know this is prime number. Okay, so somehow we can make this in the form of this. See, because if it is, if this comes a to the power p minus 1 divided by p come equal to 1, if the power is in the form of multiple of p minus 1, still this remainder will come equal to 1. All right. See, for example, let's say we have 3 is a prime number. Okay. And 4 is raised to the power, let's say 4. All right. 4 is raised to the power, let's say 4. Okay. So we know 3 is a prime number and 4 is raised to the power 4. And I am trying to apply this theorem here. So basically 4 square divided by 3 is 1. Okay, because 3 5s are 15 and this is 16. So this remainder is coming 1. Okay, and this is the application of our theorem. But still, if we multiply 2 into this, then basically what we are doing, we are multiplying a minus 1 into 2 divided by 3. Okay, we are multiplying a minus 1 into 2 divided by 3. So here what we are getting, 4 to the power 4 divided by 3, it should come 1 according to my deduction. Okay, so this will become what? This will become 4 to the power 4 is what? Basically it will be 64 into 4, which is what? Which is 256. And just try to divide this. Okay, try to divide this by 3. So you will get 8 3 times 24. All right, 3 5s are 15, and again you are getting 1 as remainder. All right, again you are getting 1 as remainder. So I hope everybody is clear with this thing as well, that if I take a to the power p minus 1 divided by p, and if it is in the form of some multiple, still I am going to get remainder as p. All right, so why I am saying this? See, now I have 107 to the power 144 divided by what? Divided by 17. All right. Now what happens here is that I know the remainder is coming to be what? 5. All right. When I, sorry, We have 107 divided by 17 to the power 144, and I know this cannot be made in the form of ax plus 1, because I will do let's say into 6, then I am getting 102 plus 17. If I will get a higher number, so I am not getting ax plus 1, this in the form of ax plus 1. So what I am doing here is that I am making this in the, I am directly taking the remainder. Okay, so this is 102, so we are getting what, 5 as remainder. So 5 by 17, and 5 will be raised to the power 144. Now we know this is a prime number. If we can make this number into a multiple of 16, because we know p minus 1 we need. Okay, so can we make this a multiple of 16? All right, so we know this number is divisible by 4. Okay, this number is divisible by 4. You can see this, 1444, last two digits are divisible by 4. So obviously this number is divisible by 4. So we have 4 threes are 12. All right, we have 4 threes are 12. We have 4 6 are 24, and we have 4 1 times 4. Now this 361 is not divisible by what 4, sorry, 4 again, because we need to make it to the power of 16, but we can still make it. How? See, we have this 4, let's say, see, so we have what? I already told you this, that we can do this in the form of multiple as well. Now we have 5 by 17 to the power 1444. All right. So how we can do this? Split this. Okay. 1440 plus 4. All right. Split this 144 into 1440 plus 4. Now try whether this number is divisible by 16 or not. So 1440 divided by 4 is what? 4 threes are 12. Alright. And 4 6 are 24. Okay. And you will get what? 0 here. Now whether this 60 is divisible by 4. Alright. Whether this 60 is divisible by 4 or not. Okay. So definitely this is divisible by 4. You can see it. This will go how many times? 80 times. Okay, this will go how many times? 80 times. So this is divisible by 4. All right, so now we know that 16 is divisible. Okay, because this is coming to be, we have two times divided this number by 4, so it is definitely divisible. All right, so we can write this as 5 to the power 16 n into 5 to the power 4 divided by 17. We can do this. Now we know remainder for this is 1, and remainder for 5 to the power 4 divided by 17 is what? Is that we can calculate this. Okay, we can calculate this. How we are going to calculate this? Just multiply. So you know that 15 to the power 4 is what? 625. All right, and this division can be done. This division can be done. So 625, you have 17 3 times is what? 51, and 17 4 time is what? 68. Okay, 68. So this will go 3 times. Okay, this will go what? 3 times. Then you have 51 here. This will go how many times? This will go 11 times. Okay, 111, 115. And you know what will be the remainder here. It will come to be, you will do this 6 times, this will come to be 102. All right, 102. So you will have 13 as remainder here. Okay, you will have 13 as remainder here. Okay, so 625 when divided by 7, you have, see guys, look at this question. You have to find the remainder for this. Okay, you have to find the remainder for this. So how are you going to find the remainder for this? So you have 107 divided by 136 to the power 144. All right, to the raised to the power 144. So now basically what are you going to do here is that 107 divided by 136. So this 136 can be split in the form of what? Um, let's say 17 into 8. Okay, 17 into 8 can be 136. All right, 17 into 8 can be 136. So we can split this number. So just write 107 to the power 144 divided by 17, and 107 to to the power 144 divided by 8. So this question is just on a little tougher side or cumbersome type. So we will see this. Now 107 divided by 8 to the power 144. When you are going to divide this, you will not get this in the form of ax plus 1 to the power n divided by a, or ax minus 1 wala format also you are not getting. So what we have to do here, just divide this 107 by 8. Okay, so what are you getting as remainder? 8 ones are 8. Okay, and 8 threes are 24. So basically you are getting 3 as remainder, because this will be 27. 27 minus 24, you will get 3 as remainder here. Okay, so when you get 3 as remainder here, just write it 3 to the power 144 divided by 8. Okay, now see this 3 to the power 1444, I can write as what? 3 square to the power 5, sorry, 7 2 2. Okay, because what I did is I just took 2 away from this, and you know, a to the power m to the power n is what? A to the power m into n. Okay, a to the power m into m. So you have 3 square to the power 7 to 2. That means what? 9 by 8 to the power 7 to 2. That becomes equal to what? 1. That becomes equal to 1. Okay, so this is what we are getting. So for this part, I am getting as remainder what? I am getting as remainder 1. For which part? 107 divided by 144. Uh, for this part, I am getting remainder as 1. All right. So, but now we have to find the remainder for which part? 107 divided by 17 to the power 144. Okay, divided by 17 to the power 144. So let's just find out for this. So remember, one kind of remainder we got, है ना? We are going on a journey to find another. Now see, this is again not coming in the form of ax plus 1. How? See this 17 when you are getting, okay. So 17 into, let's say 6. So that is coming equal to what? 102. And 17 into 7, that is coming equal to what? 119. Obviously, just add 17 here. So you are getting 119. All right. Now, see, this is coming to be what? We cannot make it in the form of ax plus 1. So 107 minus 102, what are you going to get? You are going to get 5 as remainder. So now you have 5 by 17 to the power 144. 4. All right. So but again you see, when you will see 17, then still you are not getting this in the form of ax plus 1. Do 5 square, you will get what? 25. Do 5 cube, you will get 125. Okay, but the multiples of this are what? 34, 136. All right. So again we are not getting this anything which is coming near to this. Okay, so let's see what is the remainder, how to find the remainder in this case. Now we know this is a prime number. All right, this is a prime number. I told you a theorem, a to the power p minus 1 divided by p can also be what? Remainder can give you 1. Why? Because I told you in the earlier concept when I was telling you. All right. So here what we have 17, but this number is definitely not 16. But can this number be a multiple of 16? Yes, definitely it can be a multiple of 16. How? Let's see. Okay. how to make this a multiple of 16. So we have what? We have 1444. All right, we have 1444. When this 1444 is divided by 4, so this is divisible by 4, we know this. Okay, how many times? This will go 3. So this will become how much? 6, and this will become 1. But I know now this is not divisible by 4. This is not divisible by 4. So what I am trying to do here is, if you try to make this number again divisible by 4, so just remove 4 from here. So 1440 it will become, and plus 4 you can write. Now you know this number is divisible by 4. Let's check this, that is this number divisible by 16 as well. So to simplify my calculation, I am not directly dividing this by 16. What I do is I divide this by 4, and whatever the question comes, I will again divide that by 4. So I will get 4 threes are 12 here. Okay, and um, this is what? This is 24, so you are getting 6, and then you are getting 0. Now, is this again divisible by 4? See, once we divided this by 4, so we are getting 360. Now, divide this by 4 and see. All right. So you have what? 4 eights are 32. Okay, 4 eights are 32, and this is what? This is 40. Okay. Uh, Sorry, you have 4 nines are 36. Please pardon me. Okay, you have 4 nines are 36. So this is coming to be 90. So we know 16 into 90 plus 4 is what? 1444. You got this? 16 into 19 plus 4 is 1444. Please pardon me for the silly calculation mistake here. Now you have 5 by 17 is 16n plus 4. Okay. So now this becomes 16n by 17, and this becomes what? 5 by 17 to the power 4. Okay, to the power 4. Now why I am saying that 16n will also be divisible, will also give the remainder 1. So let me explain you this thing with the help of a concept. You have, for example, say 4 divided by 3 to the power 4. All right, to the power 4. Now, if I have to apply this, then 4 divided by 3 to the square, this will have remainder as 1. Obviously, 16 divided by 3, 5 3 is 15, remainder you are getting as 1. But this is to the power 4. So, I can write it as 4 to the power 2n divided by 3 will give the remainder 1. Just check it whether it will give or not. Okay, so you have what? You have 256. 4 to the power 4 is 256. So 4 divide this, you are getting what? 8 3s are 24, and 3 5s are 15. Again, you are going to get as remainder 1. So I hope everybody is clear with this thing, that if you will get 16 and also now, still you will get remainder as 1. So how I do this? I took the help of a prime number theorem. So I got what? 1 as remainder. Now what? Now just raise 5 to the power 4 divided by 17. Whatever will be the remainder here will be your remainder. Now you can obviously solve this, because this is what? 5 to the power 4 is 625. Okay. 5 to the power 4 is 625. So just divide this. So you will get what? Um, um, I think you have to find the remainder here. So 17 into 3, you are going to get as 51. All right, you are going to get what? 51. So what will be left? 115. Okay, 115. So just do 17 into 6, you will get 102. Okay, and 115 minus 102 is what? 13 as remainder. So finally you got 13 as remainder. I know this became a little cumbersome process, but finally you got 13 as remainder. So try to do this question again on your own. This is a little bit lengthy concept. So you got 13 as remainder. Now let's just there is more that is left in the question, because we have to find the remainder of this as a whole. Okay, so once I did 117 to 144 divided by 8, I got 1 as remainder. And when I got 1 to 107 to the power 1444 divided by 136. I got 13 as remainder. Okay, so basically, we should a remainder will be such that, sorry, I did this by 17. So remainder for this number will be such that it satisfies this condition also and this condition also. So see, the number is in the form of 8n plus 1. Okay, this number, see, there are multiple numbers that can give remainder 1. So this number is in the form of 8n plus 1. So when divided by 8, this will give as 1 as remainder. And this remainder is in the form of 17n plus 13. Okay, 17n plus 13. So when divided by 17, it has to give 13 as remainder. Now, what value of n will satisfy this number? Okay, so what value of n will satisfy this number? So let's just see this. So like if you take 8 into 10 plus 1, so this will become 81, and divide this 81 by 17. What are you going to get? I think 17 4 times is what? 7 fours are 28. You have 68. You know, 5 times it, I think 85 it will become. Okay, so this is 68. What is 81 minus 68? This is what? 13. Okay, so you are getting 13 as remainder. All right, you are getting 13 as remainder. So 81 satisfied this condition. Now I did this thing intuitively. You can go and check, or you can just remember the table and do this thing intuitively. Okay. Beyond this, it is not going, because see, 8 till 8 5, you have 41. Okay, you have 41. Then nothing is happening. ठीक है ना? Then you have 8 6 of 48 plus 1 49. Okay, so either you have 34, you are getting 15 as remainder. Okay, so you have to sometimes intuitively work also. So in this case, what is the remainder we got here is 81. 81 is the number we got as remainder. So this was a very lengthy question. Just try to break it down and do this. Okay. Sometimes the question will be simpler than this, and they will be given composite number. So still you can split it into co-prime numbers. All right. And you know, co-prime numbers are those numbers that do not have any factor in common. Okay. So this was about this. Now let's move on. Students, let's just see this question. It is 73 into 75 into 78 into 57 into 197 into 37 divided by 34. Now what we have to do here is that we will again split this into co-prime numbers. Okay, we will again split into co-prime numbers. So what will happen? 73 into 74 into 78 divided by 17 into 2 into 57 into 197 into 37. All right, into 37. So we have what here? We have, this will go 39 times. This will be 30, this will go 39 times. Okay, so this number and 2 is eliminated from here. All right, 2 is eliminated from here. Now the number we are left with is 73 into 75 into 57 into 197 into 37. All right, and we have to divide this by 17. What is the remainder we are getting? So 17 into 4 is what? 7 4s are 28 to 68. All right, so when divided by this, you will get 5 as remainder. For 73, you will get 5 as remainder. Okay, and there is 39 as well here. Okay, when this is gone, okay, this is 75, so you will get 7 as remainder here. Okay, when this will go, you will get 6 as remainder. When this will go, so see, 197, so 17 one times you are going to get, and then this is 27, so again 17 one times you will get 10 as remainder. So just write 10 as remainder. Here you will get 3 as remainder, because 17 twos is 34, and here you will get 5 as remainder. So now you are left with these numbers. Okay, so let's just put it in this format. Okay, so you have basically 35 into uh, 30 into 30 divided by 17. Okay, so this you will get a remainder as 1. All right, here you will get remainder as 1. Here you will get remainder as what? You will get remainder as 13. All right, and here you will get remainder as what? Here you will again get remainder as 13. Okay, or you can get remainder here as minus 4, because 17 into 2 is 34, and this 30 is just 4 short of 34. So get here minus 4 as remainder, and here also minus 4 as remainder. So you have minus 4 into minus 4 divided by 17. That is basically you are getting 16 as remainder, because minus minus will get cancelled. So you will get 16 as remainder. So you got 16 as remainder, but you have to multiply this by 2 because you eliminated this. So you got 32 as remainder. Okay, you got 32 as remainder. All right. This is how you do this. Let us just see one more question. So this question is what? 43197 divided by 7. So I think this is very easy. You are getting this in the form of ax plus 1 by a to the power n. So what is a here? Ax here 7 into 6. Okay, we have to divide this by 7. A is 7, x is 6, plus 1, you have 43, and here obviously you know your remainder is 1. All right, you know your remainder is 1. So see, I told you the tougher questions. Now you can obviously solve the easier questions. Okay, now you can obviously solve the easier question. So now take 75 divided by 7. Okay, can guys, look at this question. You have 75 to the power 80 divided by 7. Alright, 75 to the power 80 divided by 7. So 7 is a prime number. Okay, remember this is 7 is a prime number. Divide 75 by 7. What are you going to get as remainder? Plus 5. How? Because see, you are dividing 75 by 7. Alright, 75 by 7, 7 times is 70, and then 5 as remainder. Other than that, we are not getting any remainder. So we have 5 to the power 80 divided by 7. Now see, what happens here is this is a prime number, and what we need here, we basically need p minus 1, because a to the power p minus 1 divided by p is what? 1. Okay, so if we get 6 here, if we get what? 6 here, so then our job will be done. Okay, so let's just divide this 80 by 6. What are you going to get? This will become 40, this will become 3. Okay, and this will become what? 3 1 times. All right, 3 1 times, and this will be 3 3 times, and then you will get 1 as remainder. Okay, you will get 1 as remainder. I hope I'm correct. Okay, then you will get 1 as remainder. So basically 13 you are going to get 1 as remainder. Okay, okay, so fine. So this power can be written as what? 13 into 6, which is what? 5. Um, this will become what? 18, and 1 becomes 78 plus 2. All right, 78 plus 2. Okay, so this is how you are going to write your power. You are going to write this as 16 into sorry, you are going to write 5 as 6 into 13 plus 2. All right, so this is 80. Now this is in the form of what? 6n, and we know a to the power p minus 1 into, maybe let's say anything, do n all x also, divided by p will also give you remainder 1. Okay, divided by p will also give you remainder 1. So this is our this expression we need. So we get 1 as remainder here. What we are left with is 5 square divided by 7, and this is what? 25. 25 divided by 7, the remainder is what? 7 3s are 21, so the remainder is coming to be 4. All right, the remainder is coming to be 4. So I hope everybody is clear with these questions. These are a little bit on tougher side with by what we were doing earlier, but still we have to solve some tough question as well. All right, because now the thing will get tougher. So now you have 54 to the power 124 divided by 17. Okay, you have 54 to the power 124 divided by 17. Now what you have here is 54 divided by 17. Now this 54 can be written as 51 plus 3. Okay, 51 plus 3 divided by 17 to the power 124. Okay, we again know 17 is a prime number. This will become 0 because this is divisible. So actually we have to calculate 3 to the power 124 only. Okay, we have to calculate 3 to the power 124 only. So again, can we make this in the form of 16? Because see, this is our prime number. If we can make this in the form of 16, so that will be very beneficial to us. So let's see, 124 is what? 4 times it will go. So this will become what? 4 threes are 12. Okay, 4 ones are 4. All right. So let's do 120. 120 is divisible by 16. We know how, because this will become, no, this is also not divisible by 16. Okay, so let's just say 64 we have, and we have 6 5s are 30, 80, 6 6 are 36. We have what? 96. One more 16 we can add. So we have this 12, this is 112. Can we add one more 16? No, we cannot. Okay, we cannot, because it will become 128. Okay, so let's just keep it to here. Okay, so 3 to the power 112 divided by 17. Okay, 3 to the power 112 divided by 17 into 3 to the power, how much is left? 12 divided by 17. Okay, 3 to the power 12 divided by 17. So you get 1 as remainder here. 1 as remainder here. Now you are left with 3 to the power 12 divided by 17. Okay. So what we can do here is, um, we have this. All right. So there is nothing left. We will just have to divide this time. Okay. We will just have to divide this time. Is there any other thing you can do? See, 3. Um, okay. So you have 3 into 3 into 3 into 3, let's say. So this will give you what? 81. All right, 81. 81 divided by 17. So 81 is what? Basically 3 to the power 4. All right, 3 to the power 4 raised to the power 3 by 17, and this is 81. So when I divide 81 by 17, I will get what? Minus 4 as remainder. Okay, I will get what? Minus 4 as remainder, because 17 into 5 is what? 85. So I got minus 4 as remainder. So minus 4 ka cube, okay, divided by 17. Now basically what is left? I got 64 minus 64. Okay, minus 64 you are getting. Okay, you are getting what? Minus 64. Okay, so minus 64 when you are getting, uh, so obviously you will get what? Minus 4 as remainder. Okay, minus 4 as remainder, minus 4 as remainder, because 68, 17 fours are 68, but this minus minus becomes plus, so you get 4 as remainder. So you get 4 as remainder. So you can do this in this format as well. I hope everybody is clear with these things. All right. So this is all for this class, and we have a lot of questions that we will do from now. All right. So things will become a little bit more intuitive from here, and a little bit more tough than earlier what we have doing, but still we will practice these things, okay, so that we get a hang of concepts. So we'll practice many questions in class. I'll give you practice question and answer sheet as well, and you can do it. All right, so thank you so much for this class. We'll meet in the next class.